this video, I'm going to take a look at just an individual integral. It's going to be a basic u-substitution integral after you recognize what you really need to let u be. Alright, so we've got the integral of the square root of e to the x dx. Under normal circumstances, we would probably just let the u equal e to the x. Alright, however, because that's your inside part, if I look at this as in a different way, if I rewrite this as the integral of e to the x raised to the 1/2, and then go ahead and use power rule here, power raised to a power, then I'm going to be looking at the integral of e to the 1/2 x dx. Alright, and now we can see that we should let u be 1/2 x. So that's where we're going to start with this. So we're going to let our u equal 1/2 x. I'm going to take the derivative of both sides. Du is just going to be a 1/2 dx. Solving all the way down for dx means I would multiply both sides by 2. So 2 du is going to be equal to my dx. Alright, now coming back up here and doing some substituting. The 1/2 is a u, so I'll have the integral of e to the u, replacing dx with what that equals. I'll have a 2 du. I can now pull that 2 out in front. So 2 times the integral of e to the u du. And now we are to the place where we know how to integrate e to the u. E to the u integrated is just e to the u, so I'll have a 2 e to the u plus c, and my final step is to put that 1/2 x back in, so 2e raised to the 1/2 x plus c, and technically you could stop right there, but if you want to put your answer in the same form as your original equation, then go ahead and rewrite this back as a square root, so then we would have 2 square root of e to the x plus c. So, a pretty straightforward u substitution after you see that this needs to be rewritten so that you can just more easily find that u. Definitely, thanks for watching. If the videos are helping, don't forget to subscribe and share with your friends. Thanks.